Dude, like I have the first two parts, and then it's like the third part, all it takes for the graph. Oh, it's what? Yeah, it's like I hate that we're giving these except like are you kidding? You run your own. Because I didn't know that you were going
Isn't it -2 BA or AD?
That's right. Okay, so this is chapter 16.4, and this is very similar to kinematics of, if you remember, pulleys, where we looked at absolute motion of bodies. We drew a reference or a origin or datum line, drew variables of interest, and tried to figure out a relation between them. In a similar way, this particular section you'll do the same thing, except that in this case you'll have to use trigonometry. And two very important rules for triangles are: there's the sine rule, which says that a divided by sine alpha, where alpha is the angle opposite to the side A, equals b divided by sine of beta, which is the angle opposite b, equals c divided by sine gamma. And the cosine rule, which is a way in which you can relate one side with two other sides and angle between the two. So for example, c square is a square plus b square minus 2ab cosine gamma. So gamma is the angle opposite to c, and you could do the same thing for b and a, right? And then you got to remember the Pythagoras theorem and things like that, but these are probably the new ones. So the best way to illustrate this is to solve problems. We will follow the same recipe, which is choose an origin, drop variables, and then try to relate them, and then differentiate to get velocities, acceleration, whatever is asked. So let's get started. Crank AB is rotating with a constant angular velocity of 4 radians per second. Determine the angular velocity of the connecting rod CD at the instant theta is 30 degrees. Theta is shown over here. Okay, so let's just try to translate whatever is given here in terms of variables. Since we are told how AB is rotating, I'm going to define this angle here as alpha. Okay, and what really is told to you is alpha dot equals, maybe I shouldn't use alpha because I think you might get confused with angular acceleration. Let me use something else. Let's use beta. Okay, so you're given that beta dot equals 4, and if you want to be very particular about this, you can call it -4 because it's clockwise, right? Clockwise is negative, counterclockwise positive. Okay, what you're asked is to find the angular velocity of the connecting rod. So the connecting rod is CD, and the angle made by CD with the y-axis is theta. So we are asked to find theta dot. Theta dot is the unknown. Okay, so we're given the sides. If you think of CBA, well, CBA is a triangle. We're given two sides of the triangle, CA and AB. So if I can somehow find a relation between beta, theta, and the two sides which are given to me, then I could potentially differentiate theta, get theta dot as a function of beta dot, beta, theta, and the sides. Okay, so my goal is to find a relation between those three things. So find beta in terms of theta and the sides of the triangle. CBA. Because if I can do that, I could then differentiate the expression and get beta dot. In terms of theta, yeah, and sides of the triangle. Okay, so how do I find a relation between beta, theta, and sides? So, well, I would think of laws of sines and cosines. So if I think of law of sine, okay, law of sine would be 600 divided by this angle, and it'll be CB divided by sine beta. But if I take CB, then the CB itself is an unknown, so I do not want to introduce new variables, so I wouldn't use that side. So I could potentially use this side and the angle. So let me convert 300 to meters, so 0.3 divided by sine of theta equals 0.6 divided by the sine of this angle. Okay, what's that angle? So what's the sum of the angles in a triangle? It's 180, right? So this is 180 minus theta minus beta. So I could write sine of 180 minus theta minus beta. So sine of 180 minus theta minus beta, do you know what that is? I'd want to get rid of 180. So sine of 180 minus any angle, let's call that gamma, is always sine of gamma. Right? So I'm going to use that and write here sine of theta plus beta. So I can move things around and write sine theta plus beta equals to sine of theta. And so now I think I have an expression which involves only the sides, in this case 0.3, 0.6 with sides, and theta and beta. So I would differentiate with respect to time, and get cosine theta plus beta. And then remember, it's a derivative with respect to time, so I need to differentiate whatever is inside the brackets of cosine or sine, which is theta plus beta. So it's theta dot plus beta dot equals to derivative of sine is cosine theta, and the derivative of theta is theta dot. Okay, so in this expression, I know theta, I do not know theta dot. Is that right? Yeah. I know beta dot. I know theta, it's given as 30 degrees. So theta is 30 degrees. And I do not know what beta is. Okay, so it looks like I have too many unknowns. I have the two unknowns are beta and theta dot. So can I find one of those two unknowns? How about beta? Can I find beta? So I can find that because I know from this expression that if I put, I need to, beta is the angle when theta is 30 degrees. So if I write sine 30 plus beta equals 2 sine of 30 degrees and solve for beta, right, that expression gives me beta. Beta comes out to be 90 degrees.
Can you explain how you did that trick?
This one?
Yeah, 2 sine of theta. That like your last part, 2 sine theta equals sine 30 plus theta.
Yeah, so I just put theta equals 30 because theta is 30.
Okay. Okay.
And I'm using this to find beta. So if you do this, the math with this, it comes out, beta comes out to be 90 degrees. My bad. That's, sorry, 60 degrees. That's not true. 60 degrees is the answer. So now I know beta too. The only thing left there is the, so let me write this as cosine of 30 plus 60. Theta dot is unknown. Sorry, theta dot is unknown. Beta is minus 4 equals 2 cosine 30 so cosine is 0. So this thing is 0, right?
Well, since it's multiplied, then the other side is 0, and like the theta dot minus 4.
No, theta dot is not equal to 4. What? Why?
But it's multiplied.
Yeah, so that's fine.
So then that's 0.
Yeah, so theta dot is 0. That's the answer. So one thing to know is, okay, this is, theta dot is 0 at this particular instant. Okay, when theta is 90, beta is 60, theta dot is 0. If you try to solve this when theta is, say, 60 degrees, okay, theta dot need not be equal to 0. So this thing about kinematics of a rigid body is that just because beta dot is constant does not mean theta dot is also going to be a constant. It will be a function of time. Okay, so it just turns out that it is 0 at this instant. Okay, is that clear? Okay, so this is, think of it, this is very similar to how we did pulleys. We identified variables. In this case, the variable we identified was beta, which well, we need beta because we need to find beta dot and then find relation between beta and things we know and then differentiate and then we get the answer for. Yeah, question.
Whenever you put a little arrow off to the right that says use this, and you put sine of 180 minus gamma is equal to sine of gamma, what happens to sine of gamma within that equation?
Oh, that's just a property of, there's the property of sines and cosine. That is, if you have sine 180 minus gamma, it is equal to sine gamma. So for example, if gamma was 30 degrees, this is saying that sine 180 minus 30, which is how much? It's 150 equals sine of 30. You can check it. Similarly, there's identities for what if it was sine 90 minus gamma? Then sine 90 minus gamma is actually cosine gamma. So that's a relation between how you can get rid of that 180. So that's something you're expected to know, by the way. How do you convert cosine to sine? Cosine theta is same as sine pi by 2 or 90 minus theta, right? Right? Do you guys remember that? How to convert from one angle to another based on the quadrant? So if in the first quadrant, let's see if we can do this one. At the instant theta is 50 degrees, the slotted guide is moving with an upward acceleration. So this is the guide, it's moving upward with an acceleration of 3 meters per second square. And of course theta is 50 degrees and the velocity is 2 meters per second. So acceleration is 3 and velocity is 2. Determine the angular acceleration, angular velocity of link AB at this instant. Okay, so let's not do the acceleration. I don't want you to do the acceleration. It's a little bit more involved. It's not involved. It's involved in the sense you need to take the second derivative. That's about it. But can you find the angular velocity of link AB? So find angular velocity of link AB and just pull this thing. Pull this. Okay, so what are you asked? You're told to find angular velocity of link AB, which is omega. But you can see that omega is nothing but the rate of change of theta dot, which is the same as omega. So can you find the relation between the things you know, which is theta, and there's another variable you got to link it with. Well, you know 300, that's the length of AB. You know theta, and there's a third variable which is also on the figure. You got to somehow find relation between the. Yes, it's 10:22. 10:22. I'll stop at 10:25. Point 3. I also see that there's a y here, and if I can, when I take the derivative of y, it's y dot, and y dot is related to the velocity of the connecting dot. So I'll try to find a relation from 300, theta, and y. So 0.3 cosine of theta is y. So differentiate with respect to time. minus 0.3 sine theta dot equals y dot. Sine of 50 degrees, theta dot is the unknown, y dot is equal to v, so it's 2. So from this, theta dot equals 8.7 with a negative sign. Negative 8.7 radians per second. The negative indicates that link AB is going to turn clockwise. Okay. And so if you want to find the acceleration, then you'll differentiate the expression again with respect to time. So differentiating this expression gives me negative 0.3 sine theta. I take the derivative of theta dot with respect to time, so it's theta double dot minus 0.3. Now I take the derivative of sine theta, so cosine theta, and derivative of theta is theta dot, so I'll get theta dot squared equals y double dot. So I can then sub in the values for y double dot, which is a. Theta dot is known, I know it's negative 8.7. Theta is known, theta double dot is unknown, so that is equal to alpha, and theta is known. So from that expression I can solve for alpha, which is the second part. I need to only pull the answer for the first part. As shown, rotates counterclockwise. Determine the velocity v of the follower rod AB as a function of theta. So you're not given numeric values, but you got to find v as a function of theta, and it's okay to write it in terms of the other things mentioned, which is d, r, capital R, and small r. Okay, so proceeding in similar fashion, first we'll try to find fix a datum. Now one thing to remember is, like previous problems, even for pulley problems, the datum was always a line which was chosen so that it is from a fixed point, or a point which does not move. In this case, O seems to be a good point for that. So let's choose a datum here. And the way I can find velocity is if I can find somehow find how this point A, let's call this point A, moves, then I can differentiate that point and then find the distance. Let me call this distance as x. So I'll find x, then differentiate x with respect to time, and that would be v. So it boils down to finding an expression for x. Okay, so I'm going to join this and see if I can somehow find that the side of the triangle in terms of things I know, that is theta, d, small r, and capital R. Can I find x in terms of, so this is going to be r, this length is small r. So I know two sides, well, I know two sides of the triangle. I know d, I know r plus r, as you can see on the right side, and I know theta. If I try to use well, it's tempting to use the cosine rule, right, to find x. But if I use the cosine rule, then I would have to find this angle. Right? That's the angle which comes in the cosine rule. The issue is that I do not know that angle. So I'll have to do more math to figure out that angle and then use the cosine rule. So here's another way to do it, which is let me try to find this distance directly without using the triangle, the triangle I drew. I'm going to try to find this length first. We call that 1, and then find this length. We call that 2. So if I can find 1 and 2, I can sum them up, and that's x. Okay, so x is number 1 plus 2. So let me try to find 1. 1 is, what's the length of 1 in terms of everything I know? So d cosine theta, that's 1. And then what is this? So you cannot take r plus r times cosine of that angle because I do not know that angle, or I do not know this angle.
R plus R sine 90 minus theta.
Sine of 90 minus theta. So you're assuming that this is 90, but there's nothing to indicate that's 90. You can't assume that unless you show it it's 90. Similar,
Yeah, that's theta.
which similar triangles are? They're not similar.
So this is theta. That's 90.
Okay, so here's a hint.
90 minus theta.
You know this triangle is a right angle triangle, right? You know the hypotenuse of that triangle. It's r plus r. You also know the other side of the triangle. That is, you know this side. What's this side? It's d sine theta, right?
Yeah.
Now, can you find 2? Because you know the two sides of a right angle triangle. Yeah, so that's going to be number 2 is r plus r, that's the hypotenuse squared, minus d sine theta squared. I'm using the Pythagoras theorem, but in a sort of inverse way, because I know that 2 square plus d sine theta square equals r plus r square. That's the fact I used. I try to find 2 by moving d sine theta on the other side.
That's it.
Yeah.
You can also, for 2, do like capital R plus little r cosine 90 minus theta.
That assumes that this angle is 90 minus theta.
Well, if there's a right angle, if you connect with a right angle,
It's not a right angle. You can't.
knock it out with a right angle.
It's not a right angle, no. It looks like that, but it may not be a right angle triangle, because what happens is as the follower moves back and forth, that angle keeps changing. And so at this instant, it looks like 90, but may not be the case. So if I gave you theta is 30, maybe it is 90, but if theta is 15 degrees, it may not be 90. So because the geometry changes, so you can't assume that. So this is the expression for x, and then it's just a matter of differentiating with respect to time. Okay, and the derivative is x dot, which is the velocity, which is what I'm asked. I'm going to quickly write this because that's not very important. 2 sine theta cosine theta dot divided by okay, if you get such a problem, I'll probably give you numeric values, so it's much easier to solve this than solve it as a function of different variables. Okay, that's the answer. Okay, is it clear? Questions?